Say you're in the market for selling your house, but you can't determine what should be the best price to list or what offer you should accept. Today, I'll model a simple decision tree and show you step by step how to derive the right selling price using the concept of the utility function and certain equivalents. Let's start the SpiceLogic Decision Tree software. Click the Setup Criteria button, then click the regular single or multiple criteria-based analysis button. Now select Maximize, then enter Selling Price. Now click Proceed. Click Numeral Type. Now you need to determine some variables. The first variable is that your house must have a confirmed selling price. It's a house, real estate. You must be able to sell it any time if you're offered a certain low price, right? Of course, you won't do that, but think about it as your worst case scenario. When you have no other option, or say you've waited a very long time and you really can't wait any longer. At that point, you will sell that house at that low price, which you'd consider your minimum selling price, which is possible to get at any time. That could be $1.5 million, $2 million. Think about it. You know your market, right? So, based on the situation, there must be a price point at which you're 100% confident that if you list it at that price, anyone will jump to buy the house right now. Say that price is $1.5 million. If you'd need to wait a long time and then sell for that low price, you'd need to deduct some additional operating costs like mortgage, property taxes, etc. So say that amount would finally be $1.45 million. Enter that 1.45 into the lowest selling price box. Now, think about your realistic dream price. What would be the maximum possible price you think you can get for your house if you wait long enough? Maybe $3 million? Okay, enter it here. Check the box I want to use a utility function, then proceed. Now, you need to define a set of data points that will represent your utility value for various selling prices. Of course, you'll be 100% satisfied if you get $3 million. So, keep a data point at $3 million at 1. But what about 2.7 million, 2.8 million, etc.? Are you sure that you won't be happy if you get an offer like that? Think about it. Maybe 95% happy, right? Okay, no problem. Double-click to create some data points for these prices and drag and move them to indicate that you would be 95% satisfied. What about a $1.5 million price? If you'll be totally unhappy, the level of satisfaction would be 0. So have a data point at $1.5 million as 0. Please note that our satisfaction does not increase linearly, so it can be a curved line like this. Now, proceed. Answer no here. Create a decision tree that begins with a decision node. Then add a chance node to the action node. Under the chance node, you need to create a couple of events. Create an event to represent a situation where you got the $3 million offer. That is your dream state. Name it a dream state. Then create another event that represents the worst case, where you had to wait 6 months and then you sold the house with a minimum price of $1.5 million. Now set payoffs to these events. For the dream state, the payoff is $3 million. In the worst case, you will have $1.45 million after the running costs. Now, about the probability. Do some market research and think, what is the probability of getting your dream offer at your current market? Say 80% or 70%? Think. It doesn't need to be very precise as no one knows the future. You can only predict, and that's what you need to do now. Predict. You thought right now it is a seller's market. The probability of getting your dream price is 80%. So, okay, set it here. In such a case, it will be highly unlikely that you would need to wait 6 months and eventually sell it for the lowest price. That unfortunate event probability is auto-calculated as 20%. Now, see the magic. Remember what certainty equivalent is in economics? Certainty equivalent is a number that you will happily agree to trade in a risky situation. Based on your utility function, the software has calculated a certainty equivalent. Expand the Options Analyzer panel, browse through the carousel, and locate the chart for certainty equivalent. You see, it has calculated the selling price for you as $2.27 million. You probably wouldn't or shouldn't wait any longer if you get an offer for at least this price. Now, simulate a situation of a buyer's market where there is a low probability of getting a good price. Say the probability of getting $3 million is just 50%, not more than that. Change the probability. Now, see the certainty equivalent. The software is suggesting that in the case of that bad an economy, if you get an offer from someone who will pay $2.07 million, then probably you wouldn't refuse. Now you may wonder, the software just told me a number and I need to believe that this is the price that I need to sell for? What's the reasoning behind this number? Okay, create another decision action node and name it Sell at a Recommended Price. Then set the payoff to $2.07 million and see the utility value for this selling price. You see that the utility value for selling this recommended price is 0.5. Now, see the expected utility for the risky action is also 0.5. So, that means by selling at that recommended price, you become indifferent between these two actions. Any offer greater than $2.07 million will give you higher expected utility than the expected utility of waiting. I hope this has helped you learn how to determine a rational selling price for a house and that you'll be able to apply this knowledge to sell anything. Of course, there can be many other variables that will need to be included in your model. Today, I've just displayed a simplified example. Please don't hesitate to reach out to our help desk if you have any questions regarding our decision tree software. Thanks for watching.